So in example 3, we're being asked to find the slope of a line that's perpendicular to a given line. First thing we need to actually know is what is the slope of the line that goes through E and F. So to do that, we'll graph out those 2 points. E is at 2, 3, which would be right here. Go back. F is at -4, -1, which will be there. Let's draw that a little more accurately. And the line would look about like that. I don't have a straight line drawing tool, so I can't go absolutely perfect. So if we take a look and we draw out a triangle, the slope for line EF, we're still looking at rise over run. The rise would be 4, the run would be 6, which would simplify down into 2/3. I'm going to leave the graph for a moment and go back to the questions. So what we know so far in A is that the slope of EF is 2/3. However, the question's asking us for the slope of a line that's perpendicular. So now that we know that EF has a slope of 2/3, we can go and we can find the perpendicular slope. That would be the negative reciprocal, change the sign, flip the fraction. So the slope of a perpendicular would be -3/2. B, now this is asking us to find the coordinates of a point so that we can make a perpendicular line. Well, if we look at the slope of our perpendicular, -3/2, we know what our rise is, -3. We know what our run is, it's 2. So that's going to allow us to find a second point to make our line from E to G. So going back, we need to find a point G. Well, to find the point G, we need to go from our existing line EF. So I'm going to go from F. Taking the slope of -3/2 means we go down 3/2. That point there, that's the point we'll call G. And then the lines from F to G, the line from F to G would make a perpendicular line from F to E. So what are the coordinates of that point G? Well, point G is at 2, -4. That's not the only point we could have chosen. We could have actually gone from E, moved down 3 and over 2 and found a different point. It would still be equally right, it would just be in a different position.